This is the tutorial for Chapter 10, Section 5, titled Graphing Square Root Functions. And so let's take a look at our first type of problem. It says we're supposed to find the domain of each function. So domain represents the possible x values. And so what we're going to do to find out what those possible x values are is, since we've got a radical sign, we are going to set x plus 3 greater than or equal to 0. Because if we're going to have a real number, we don't want x to make a value that's negative underneath the radical sign. So that's why we're setting it greater than. So this means that we are going to end up having a positive number or 0. So we want a positive radicand or 0. And so that's what we're going to end up looking for. So here I'm going to subtract 3 from all sides. I've got x is greater than or equal to negative 3, and that's going to end up being my domain. So that tells me that the smallest value of x can be negative 3, and then I can pull any value larger than that as well. So we do the same thing. So again, this extra 4 here doesn't really affect the problem when I'm trying to find the domain. All I care about is the work underneath the radical sign, the radicand. And I'm going to set that radicand greater than or equal to 0. So I go ahead and subtract the 10 from all sides. So I've got 2x is greater than or equal to negative 10. Dividing by 2 gives us our answer. X is greater than or equal to negative 5. So that's the smallest value I can have. That's where the graph's going to start. And then the graph's going to get bigger from there. X values are going to end up getting larger. So again, same thing here. This negative 3 outside the radical sign does not affect the domain. All I care about is the radicand. 2x plus 7 greater than or equal to 0. And so from there, you just go ahead and solve. And so we are left with 2x is greater than or equal to negative 7, so you divide by 2, and you get your answer. X is greater than or equal to negative 3.5. So that's the domain. Again, those domains tell us where along the x-axis this graph is going to end up being. So what this tells us is that at negative 3, so if this is 0, at negative 3, 1, 2, 3 spaces, that's where the graph's going to begin. This graph's going to end up looking something like this. We're going to go over that next, but what that means is the values of x are from negative 3 on up to larger values, anything bigger than negative 3, and so that's what we're looking for. So let's take a look at the next set. It says make a table of values and graph each function. So I'm going to end up using the graphing calculator, or at least the Casio FX 300, and what I'm going to end up doing is, first thing I'm going to do is find the domain of the function. So even if you're using a graphing calculator or coming up with a table of graphs, you still have to be able to understand where to start, because it's going to ask you what's your starting value. And so we still need to find the domain. That's the important thing. So x is going to be greater than or equal to negative 2. So what that tells me is that the x values are going to start at negative 2. So what I'm going to do is I'm going to use the graphing calculator, and I'm going to press the table button. So I go to mode to start with. So I press mode, and then I enter table, and then from table, what it's going to ask for is a function. It's going to have this expression, the function notation, and you're just going to enter the x plus 2. So you enter this, and then it'll ask you for a step value, where to start, a starting point. And your starting point is going to be negative 2, because that's what I started at. That's the smallest value. Now, where do you want to end? Well, let's just go ahead, and we're not going to do a lot of points. Let's go ahead and end at maybe positive. Let's end at positive 2. And so I'll go ahead and have a step value. Step value is what kind of interval do you want to use? I'm going to just use a step value of 1. And then I'm going to press equals, and it's going to give me this table. And so I've got x and y values, and it's going to list the x values and the corresponding function from that value. So at negative 2, it's going to be 0. At negative 1, it's 1. At 0, when I plug in 0 for x, I end up getting 1.41. And that number continues on, but that's just rounded to the hundredths. And then for 1, I get 1.73. And for 2, I get 2. So now I can come up with what this graph looks like. So on my x-axis and my y-axis, I'm going to go over 2 spaces to the left, and then I put that dot. That's where it starts. Negative 1, 1, so you go over 1 space, to the left from the origin, up 1 space. Over 0, up 1 4/10. And then up over 1 space to the right, just not even 2, but just a little bit above. If I go over 2 spaces, then I am up at +2, so I'm right at that spot. So you can kind of see this graph ends up going up kind of quick, and then definitely levels out and almost goes flat, it looks like, and that's what that graph ends up looking like. So same sort of thing on this one. Again, you don't worry about that +1. That does not affect the domain. For the first part, you just set the radicand greater than or equal to, so let me get that correct now, x minus 3 greater than or equal to 0. So I end up having to add the 3 to both sides, and it gives me my starting value. I know now to start at +3. So I'm going to go ahead and do the same thing. I press mode, table, enter the function, and make sure you enter the +1 because you need to enter the entire function. And I would start, I'm going to start at 3, and I'm going to end, let's go ahead and end at maybe 8. So that'll give me about 6 points there. Actually, that'll give me, 6 points. And so from there, I'll do a step value of 1, and that just means I'm going to do 3, 4, 5, 6, 7, and 8. And so when I do that, this is my table. I end up getting an x value starting at 3, I get +1. Starting at, or going up to 4, I get 2. At 5, I end up getting 2.4. And then at 6, I end up getting 2.7. And at 8, or 7, I get 3, and at 8, I get 3 2/10. So these were the values off the table that the calculator gave me, and from that point, I can graph these points. And so again, if I didn't have the calculator, I would still do the same process, except I'd be doing this work. I'd be plugging in the number to get the value. So you can see if you plug in 4 for x, we'd have 4 minus 3 makes the square root of 1. The square root of 1 plus 1 is going to give me 2, because that's 1 plus 1, it makes 2. So that's how I'm getting the value. It's just the calculator will do this work for me. So I'll go ahead and graph that function, and I'll start at +3, so I don't need much of a negative axis at all. So I'm starting at +3 on the x-axis, going up 1 space, and then I'm going over to 4, and I'm going up to 2. And then from there, it looks pretty much like the other one did. So if I go over to the next value, I just go up a 4/10 of a point. And then go over another point, I go up another, just up to 7/10 of 2. And then at 7, I finally make it up to 3. And then at 8, it's 3.2. And so it looks kind of like that. Very similar to the last one, exactly the same graph. The only difference is it started in a different spot. So on this one, same sort of thing. You just take the 4x plus the 12, 4x plus 12, you set it greater than or equal to 0. Subtracting the 12 gives me 4x is greater than or equal to -12. So I divide by 4, and x is greater than or equal to -3. So that's where I'm going to start. So my start value is -3, and I'm going to end maybe at +1, and I'll go ahead and do a step value of 1 as well. And so when I do that, this is the table I'm getting. And so when I plug that in, I got -3, -3, -2, 11. So it goes up really fast. It goes up fast because of this +7 that's being multiplied by the radical. -1 brings me 16.8, so it's going up much quicker. And then at 0, I end up getting 21 2/10. And for 1, I get 25. So again, you can see it. When you plug 1 in, 1 plus 4 makes 5, plus 12 gives me 5 and 12 give me 17. So when I go ahead and take that square root, multiply by 7, take away 3, you can see how that number is going to end up getting up there quite quick. So we go ahead and plot some of those points, and I'll go ahead and just sketch a little bit of what this graph looks like. So I'm going over 3 spaces. So 1, 2, and 3, and then down 3, 1, 2, 3. And then from there, I have to go up over -2, but up 11. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so over 2 spaces to the left, up 11. So you can see how this one's going to end up going up much steeper. But then once I hit that first point, then it starts to taper off as we go. So it's going to kind of have that same general shape where it goes up quick at first, but then tapers off as you go. kind of a quick rendition of what that looks like. Let's take a look at the the last two problems here. It says the distance the car skids in feet on dry asphalt is modeled by this function, where s is the speed of the car in miles per hour upon sudden braking. What are the domain and range of the function? Graph the function. What is the distance that will indicate a speed equal to or greater than 56 miles per hour? So the first thing to do is, in order to find out what that function is, I'm going to set 21d greater than or equal to 0. And that's going to end up giving me my domain. And so this is the domain. And when I go ahead and divide by 21, you see I end up getting d is greater than or equal to 0. And so 21 goes into 0 times. So that's the domain. The range represents the possible y values. So this is y values. And so our range, since s represents the speed of the car and the car cannot go negative, that means that we have r is going to end up being greater than or equal to 0, because it can't have negative speed. And so from there we can go ahead and come up with some values. And so we're using 56 miles per hour is the speed at which we're doing this, and we're supposed to graph this function as well. So doing a quick graph of from this value here, we're going to end up starting at 0, and then when we go ahead and plug in some values, so again I'm just plugging in using the variable, it says f of x still in my function notation, and instead of pressing D I have to use x. And so my x values, I just picked a couple here. I started at 0 and then I just did 1 and 2. And so I just did a start at 0, end at 2, do step values of 1, and that gave me 0, 4.6, and it gave me 6.1. And so when I go ahead and graph this, I have over 0 up 0, and then going over one space to the right brings me up 4, so 1, 2, 3, 4. And so I'll go up just a little bit more than that, though, to 4.6, and then over 2 brings me up to 6.1 or so. So it looks like this. So you can see how, again, it goes quick to start with, but then it kind of starts to level out as you go. So that's kind of what the function looks like. And so what they wanted to know was, if the speed were 56 miles an hour, what is the braking distance will indicate a speed equal to or greater than 56. So let's go ahead and substitute 56 in for s, for the speed, and then do the work. So I'll take this value and square it to cancel out the radical sign. So I'm left here, in this case, with 56 squared, and that gives me 3,036 equals 21d. So when I go ahead and divide by 21, dividing by 21 on both sides will end up giving me a value of 149.3 repeated, and these are in miles per hour. Feet is the distance. And so that's what my distance is. So it looks like anything at 149.3 repeated miles or feet is going to end up telling us that that speed was 56 miles an hour or greater. So we'll say distance greater than or equal to. I'll put it in this sense because we wanted a speed that was 56 or greater. So let's take a look at the next one here. Here it says that we have Stacy's designing a soup can, and she wants to find out it must hold 32 cubic inches of soup. And what is the radius that must be approximately half the height? The radius is half the height. And so let's go ahead and say the radius is half the height. So the radius is equal to 1/2 the height. And so I know that radius equals this, so I'm going to put in place of the radius 1/2 the height equals the square root of 32 over pi h. And we're taking the square root of that. And so what is the range or domain of the function? Well, the domain is going to be anything that h has to be greater than or equal to 0. It's actually, it has to be greater than 0 because we can't have a value 0 in the denominator. So I'm going to say x or h is going to be greater than 0. Again, that's because can't divide by 0. And for the radius then, the range value, my range, if that's the case, r is going to also be greater than 0. And so from there, I can go ahead and graph my function. So I have an understanding that the function looking like this. Here's my height, and here's my radius. And it's going to have that same general shape. So I know it's starting here, except it's going to be an open circle. So I'm going to make an open circle right here because it doesn't equal that. And I know I'm going to have that general shape. It kind of looks like this. And so again, they all kind of look like that. This one I kind of had forked a little bit here, but they kind of all have that general shape where they go up kind of quick to start with, but then they peter out as they go. And so now we want to find out what the height should end up being, and the radius as well. So I'm going to set h, 1/2 h equal to that square root. I'll rewrite it here. 1/2 h equal to the square root of 32 pi h. And when I go ahead and square both sides, I'll square this side here, I'll end up with 1/4 h squared equals, and then I have 32 over pi h. So I'm going to go ahead and multiply both sides by h, or actually I'm going to go ahead and multiply by pi h, and that'll cancel out my denominator so I don't have to deal with that anymore. And so now I've got this. I've got 1/4 h to the 3rd power pi equals 32. And so from this point I can go ahead and multiply by 4 and divide by pi on both sides. Multiply by 4, divide by pi. And so when I do that, that gives me 128 over pi equals h to the 3rd power. So I'm going to take the cubic root this time. The cubic root to cancel out that cube symbol. So I'm getting h equals about 3.44 inches, and that's what they want. So they asked for what should the height of the can be, and that's about what the height I end up getting. So those are the types of problems you're going to see on tonight's assignment. Good luck.